Good morning all. Welcome to Algorithm Design and Analysis video. This is Swapna. So today's our topic is in performance analysis. Space complexity. So space complexity of a program is the amount of memory it needs to run or to complete the program from starting to end. So this amount of space we can calculate by using the two components. Fixed component, variable component. Already we know performance analysis is using the analytical approach to get the performance analysis of your one program. In that 5 factors are there: time complexity, space complexity, network, power, CPU registers. In that second one factor is space complexity that we are going to know. So amount of space needed by the program to complete the execution. To find out that we are calculating the two components, that is fixed component and variable component. In fixed components, what are the things will come in fixed component to find out the amount of space by the fixed component is instruction space, space of the sample variables, space of the constant variables. And this fixed component is independent of input and output. Whatever may be the input size you are giving, whatever the values you are giving as input and what you are getting as output, it is independent. Fixed component contains instruction space, space of the sample variable and constant. These are the three components mixed we can call as a fixed component. One more component is variable component. In this variable component, which type of space we are considering is space needed by the combined compound variables and whose size is mainly depends upon the input and output. So, to complete the program execution, if the compound variables we are using and loops we are using, within that statements, if you are within that some more statements are there, iteratively we are calculating and we are updating. At the runtime to do the execution, it uses the temporary space, that is stack space. So every time it is updating within the one iteration, at last till that point, it uses the dynamic spaces with the dynamic type of execution, and at the time of execution, it uses the temporary spaces like stack space, heap data structures, and other type of data structures. So here, variable component space mainly depends upon the input size and also temporary spaces where we are using to complete that execution. That is also comes under the variable component. So this is about the variable component. In fixed component, we set instruction space and sample variable space. So within that instruction space, what is instruction space is? It is a space needed to store the compiled version of the program instructions. Once the program is loaded, after the compilation, it generates the one version of compilation. That space is instruction space. It is fixed and it mainly depends upon the compiler. Which type of compiler it is using and how much time it is taking to complete that one and what is our target file after the compiler version. Depending upon that, this amount of space is fixed. So that we can call as a instruction space. For this example is, if your program you written by using the Java program, after the compilation, it will generate the class file. So amount of space to store the class file, that we are calling it here as instruction space. In fixed component, sample variable space is there, constant variable space is there. In variable component, compound variable space is there. This total, the amount of space related to variables is considered as data space. Data space is spaces needed to store all the constant and variable components, all the constant and variable values. So data space contains constant and simple variable space required for constant and simple variables and space required for variable components set like dynamically or at the time of execution, which are related to object space, size of the arrays, class instances. Depending upon whatever the size of the array you are giving as input, depending upon that that amount of space is allocated for that particular array. For example purpose, if I specified array as one element only, it is data type of integer, it can give the space of 2 bytes only. And if I am at the runtime I specified array value contains the 3 elements, then these are the integer data type, it needs to allocate the space for 3 elements, 3 integer values, 2 bytes, 2 bytes, 2 bytes, 6 bytes. So automatically it dynamically changes depending upon the input. So whatever the variable components are, that are depends upon the input and output. Whatever the fixed components are, that are fixed. It doesn't depend upon the input and output. So I think this is the clear to calculate the space complexity. And one more type of thing is there, that is environment stack space. It is used to the information aid to resume the execution of partially completed functions. What is the environment stack space? So already you may know about the operating system. In that CPU type of CPU algorithms are there to assign the one particular program to the CPU to complete the execution. It follows the some type of algorithms. In that, for example purpose, I am taking the round robin thing. Round robin thing, here there are 3 programs are there. Within that, for every program it allocates some fixed amount of time, 2 minutes. After that it is going for the second program. After 2 minutes it is going for the third program. After the third completion, once again it comes to the first program. Till that time, temporarily whatever the execution is completed for the 2 minutes, it temporarily stores in a one particular stack. Once again, whenever turns come to the first program, it resumes that execution. It uses whatever the temporary updated information. Like this, partially completed functions, partially completed program information, temporarily it stores in a one particular stack. So that type of space we can call as an environmental stack space. So this also comes under amount of space required to complete the one program. So these are the components we are considering amount of space required for the completion. So to calculate this for that particular algorithm, what are the steps we are considering this? How many number of variables are there, and for every value with some default values or some initialization, which type of variables we are using. After that, finding the compound variables or variable component like objects, arrays are there dynamically, which changes. Depending upon that, we will calculate the space required for the one particular algorithm. So this is about the theoretical part. Till now what we have completed is to find out the amount of space required to complete the program execution. 2 components we are considering: fixed component, variable component. In fixed component, it contains the instruction space and space required for the some variables, like sample variables and constant. In variable component, it is considering the space required for the compound variable objects, arrays type of instances and class instances, and temporary stack, temporary data structures, and environmental stack. It is also comes under the variable component. Summation of these two components, we are considering amount of space required to complete the algorithm. So to understand it better, we are going for one example. Here I am taking one example. Here I am taking one example. So this is the summation for one particular array. So it contains the one array, number array. That means it contains the variable component, and also some fixed components are there. That is instruction space already there, and some fixed variables also, example variables. So here we are finding the summation of elements present in the number of array. This depends upon the size value. Whatever may be the size, depending upon that value, that many elements it stores in a number. So to find out that, I already told you, find out what are the variables we are using in that algorithm, which are fixed, that is constant or sample variables are there, and which are changing like dynamically depending upon the input, like arrays and objects. So in this fixed components are one result is there. So for that purpose, instead of specifying in the form of bytes, I am specifying 1 unit of size or 1 word of size I am specifying. Because depending upon the programming language, what is the amount of space allocated for the particular variable changes. So example purpose, data types, bytes stored Number of bytes for the integer variable in C programming languages changes from the number of bytes for the integer variable in Java changes. So that's why we don't know which type of programming language we are using to complete the execution. So instead of that, for every variable, I am considering 1 unit of size or 1 word of size. So what are the fixed components are there here means one result is there to find out the summation of that one. This is the fixed one, and for that 1 word is there. It doesn't depends upon the input and output. And one more is count value. It changes every time. It first assigns the value of 1. This one is also fixed. It doesn't depends upon the input. So for this also 1 unit is there. Number array. So its size is depends upon the size value. So that is we don't know. That I am considering as a 1. And size value is also fixed. At the time of giving as input, I will give you one particular number for the size. It may be the 2, 3, or 10, or 11, 20, like that. But size is fixed, 1 unit. So here fixed components are result, count, size. For every component, 1 unit of time. Only for number array, it depends upon the input. Only number array value, how many number of elements it will store in a number array depends upon the input. So that we don't know, that we are considering as n. So what is the size amount of space required for this algorithm is 1 plus 1 plus 1 3 plus n, 3 plus 2. So this is also we are representing in the form of function. So that's why I am taking here S of n. S of n space complexity of this function is this algorithm is 3 plus. If I am specifying what is the degree of this one is I am representing with the big O of degree of this expression is highest degree variable is n only, 1 only. So O. Big O of n. Order of this function is n. Order of this function is n. So this is the replacement. This is the example how we can calculate the space complexity. And if it is fixed, then we can call it as a constant space complexity. If it is varying in linearly, then we can call as a linear space complexity. For this, I am not specifying anything. To find out that constant space complexity, here I am taking the one more example. In this example, what I am doing is finding the square of one particular element. Finding the square of one particular element. So, here in this variable is only one variable is there. After finding that square of that variable value, that is only storing into the same variable. So, in this algorithm, square and a return a multiplication a. So in this algorithm only one variable is there and that is fixed. So it requires only the 1 unit of space. So that is we are representing in the form of space complexity. S of n is equal to 1. 1 is the constant value. So what is the order of this function is order of 1. So constant value only it is containing in this complexity. That's why this type of space complexity we are calling constant space complexity. And one more example for this is integer same thing. Finding the whatever the example we covered in this, that comes under the linear space complexity because degree of this variable is that is the example. Next, here I am taking the 2 examples. For these 2 examples, we are finding space complexity and time complexity. How to find the time complexity that is covered in previous video. If you want to once again detailed information, go through that. Performance analysis time complexity video is available in my channel. So just go through that. And here I am taking the 2 examples. For those 2 examples, I am finding the space complexity as well as time complexity. So what we are doing in this algorithm is simply swapping the values of A and B. I am taking the 2 values for this A and B and simply swapping A value into the B value into D. So for that purpose, this is the code. Temporarily A is equal to A is equal to B, B is equal to temp. That is temporarily A value is storing into the temp variable. After that, whatever the B value is there, that is storing into the A. From the temp, I am storing that same value into the B. So now values are interchanged. To find the space complexity, what are the conditions we have specified, what are the rules we have specified means how many variables are there, is there fixed variables or dynamic variables, find out. In this algorithm, only the 3 variables are there, that is A, B, temp. 3 variables are there. These are the fixed one, for every variable 1 unit of space or 1 word of space. So what is the space complexity of this one is 1 plus 1 plus 1, 3. space complexity is 3. What is the order of this one? Space complexity, it is containing constant value. So order of this function is big O of 1. Is that clear? For this algorithm, it contains 3 variables. The 3 variables are fixed because here we are assigning some values to the 3 variables. These are not arrays, these are not instant variables. So it doesn't depend upon the input. Simply whatever the value is there, that is fixed. That is fixed. We are simply assigning that value. It is not iterating purpose and it is not continuing, it is not varying. So fixed components. For every variable, one word of space it is assigned. That's why we are getting the space complexity for this algorithm is 1 plus 1 plus 1. Now we are going to find the time complexity. Already we know how to calculate the time complexity. If you are writing in the form of step table, that we are calling as a step table. Instead of writing the step table, simply I am calculating the time complexity here statement by statement. Because it doesn't contain any loop, any recursive functions, simple statements are there. For to find out the time complexity for this declaration, 0 steps only. For opening brass, 0 time only it is taking. To assign the A value to the temp, for the execution purpose, it uses 1 unit of time. And to assign the B value to the A, for this statement also, it uses 1 unit of time. To assign the temp value to the B, it is also uses 1 unit of time. For close the process, doesn't use the any CPU time to process them. So, how much time it is taking totally means 1 plus 1 plus 1. 3 units of time it is taking. So, it is represented in the form of function f of. Order of this time complexity is also constant. That's why we are writing order of this time complexity is big O of. Like this, for any algorithm, we can calculate the space complexity as well as the time complexity. These are the 2 components are important to find out the performance analysis of a algorithm. This is analytical approach. So, to understand better, to understand in detail, one more example I am taking. Same example only which is previously covered in space complexity and time complexity. Finding the summation of array elements. Array size is n. That means n value depending upon the input value. N value changes depending upon n, array elements will change. So once again I am finding the space complexity, time complexity. That means here I am repeating this example. At the same time we are calculating the space complexity, time complexity. So to find out the space complexity, what are the fixed variables are there? What are the variable components are there? Fixed component, variable component. So here n is the variable component. N value is fixed. N value is fixed. It is a fixed component because we will give the once only one value, some value to the n. It assigns that value. So that is fixed component. For this 1 unit of space it is required. And I is also fixed. So for I is also 1 unit of time. And sum is also fixed. For this also 1 unit of time. This variable component is array. Only one array is present. There is no class instances objects. So array is variable component. Its size depends upon the n units. So what is the space complexity of this one? 1 plus n plus 1 plus 1. So n plus 3. So if you are representing it in the form of function, that we are Sn of x1. Order of this one is big O of. And what is the time complexity for this? For this statement, 0. For opening braces, 0. For this statement, this is the assignment of statement. So it executes only the ones. Assignment of statement, it executes only the ones. So for this, it requires only the 1 unit of time. And next one is this is the loop. So till I value is less than n, till I value is less than n, it is true. It enters into this one. When I value incremented more than this, then it checks this condition. That means it is executing more than n times, and it comes out from the loop. So that's why it is executing how many times? N plus 1 times. And this statement, how many times it will execute? For every time once, but how many times it is repeating this? Till I value is 0 to n. That means it is executing n times. Till for loop is true, that many times it is going into this condition and executing, going into this condition and executing. Last I value is n plus 1, then only it comes out, then it is not executed. So this statement is executing n. After that, whatever the sum value we get, that is updating or rated. So this statement is also executes 4 units. How much time it takes? 1 unit of time. So what is the total amount of CPU time it requires? Means 1 plus n plus 1 plus n plus 1. So total time complexity that we are representing with f of n, how much amount of time it requires means 2n. What is the order of this degree of this function, and order of this one is n. So these are the two examples I covered in this video. By this, you can understand easily how to calculate the amount of space required, how to calculate the amount of time it is required to complete the execution. Is that clear? So one more example here for this is frequency count method. That means here we are using the three matrices, doing the addition of two matrices and storing into the third matrix. To find out the time complexity and space complexity, once again we are we can calculate for this. So this is the algorithm. A and C is the one matrix, A and B are two matrices, size of n. By adding these two matrices, we are updating summation of this. To do the summation, we are using the two for loops. And space complexity means how arrays means these are the dynamic one only, and depends upon that. Yeah. And how much amount of space it is required means it is using the two-dimensional array. If it is a single dimensional, depends upon the n value, that many elements it stores in an array. But it is a two-dimensional array. That means it requires n square space for that particular A matrix, and also n square space for the second matrix, and n square space for the third matrix, which stores a result. So for these three matrices, it requires n power 2, n power 2, n power 2. And particular to know the value of this particular variable, it requires one word of space. For the iteration purpose, I am using the I variable, j variable. For I variable also it requires 1 unit of space. For j variable also it requires 1 unit of space. Total amount of space it required for this algorithm is 3n square plus n square plus n square plus 1 plus 1 plus 3n square plus 3. What is the degree of this one? Here variable is n and highest degree for this is n square. So order of this function or degree of this function is big O of n square. So this is the space. Again, we need to calculate the time. For this, 0. For opening braces, 0. For this loop, till n value, it continues. After that, n plus 1. I value is n plus 1. Then it checks that one and comes out. So, how many times it is executing? N plus 1. And within the for loop, till n value, it enters into the loop. That means this statement executes first n times. And what is this statement? This statement also containing one for loop. And how many times this for loop will execute? Till n plus 1. So, n into n plus 1. And this statement enters if these two for loops are true. So, for this for loop, it executes n times. For this for loop, it executes n times. So, how many times this statement is executing? N into n. What is the total time complexity? N plus 1 plus n into n plus 1 plus n square. So, total time complexity required for this algorithm is 2n square plus 2n plus 1. And order of this time complexity? Big O of n square. Big O of n square. This is the example for frequency count method. This like this we can calculate the time complexity and its space complexity. To understand one more thing, here I am using the same matrices type, but instead of addition, here I am doing the multiplication. And we are finding the time complexity as well as the space complexity. Here it is also using the loops, that's why we are calling it as frequency count. And first, once again, I am calculating the space complexity. Find out that space complexity, what are the variable components are there, what are the fixed components are there. Variable components here is A, B, C array. These three are two-dimensional arrays. How much amount of space it requires for this two-dimensional array? For A, n square space. For B, n square space. For C, n square space. And what are the fixed variables are there? N is there, I is there, J is there, K is there. So for n, 1 unit, 1 word of space, for I, 1 word of space, for j, 1 word of space, for k also 1 word of space. Total amount of space required, n square plus n square plus n square plus 1 plus 1 plus 1 plus 3n square plus 4. What is the order of this function? In this expression, one variable is the n. What is the highest degree of this variable? That we are considering as order of this function. So, we go off. For the summation purpose, for the multiplication of two algorithms also, same amount of space it requires. Same amount of space it requires. So, previous example only that one. So, 3n square plus 1 space required for summation of two matrices. Same thing, 3n square plus 4. One more constant extra we are using k for multiplication. So, this one it requires 1 unit of more space it required for the multiplication. That's it. Now, we are going to calculate time complexity. Time complexity for this statement 0 elements, for this 0 units of time, for this loop n plus 1. And if loop is true, this statement will execute n times first, and this statement also containing for. So, it also executes n plus 1. So, n into n plus 1 for this statement. And if this is true and this is true, this statement will execute for this loop n times, for this loop n square. And this also. These two are true means it executes n into n. And this statement simply assignment means simply it is taking only that time only. But once again it is containing loop. So this loop also executes n plus 1. And this statement simply assignment doesn't contains any loops. So for 3 loops, for 1 loop n times, for 1 more loop n times, for 1 more loop n more 1 more time. So total time units of time required for this statement is n. So summation of all these units of time, total time complexity n plus 1 plus n into n plus 1 plus n square plus n into n plus 1 plus n cube. So this times we will get 2n cube 3n square plus 2n plus 1. What is the order of this function? Highest degree n with cube. So order of this is equal of n cube. This is the time complexity and space complexity. How we can calculate amount of space required, amount of time required to complete the algorithm. By this I am ending this video. We meet in the next video with the to know the what is big O. What is the big O notation? Asymptotic notation. By this, main two factors were to find out the performance analysis of an algorithm is completed by this video. Thank you. Meet in next video.